Hello everyone, welcome to another video lesson discussion in general mathematics, which is solving exponential inequalities. And these are our learning objectives: solve exponential equations and inequalities, and solve problems involving exponential functions, equations, and inequalities. Last time, we defined exponential inequality as an inequality in one variable having a variable in the exponents, and here are the examples. Just like solving exponential equations, we will still apply the laws of exponents and the equal power rule in solving exponential inequalities. You can find the link below on how to solve exponential equations. Furthermore, we will also use the property of exponential inequalities. For example, if b is greater than 1, then b raised to x is less than b raised to y if and only if x is less than y. This means that the exponential function y is equal to b raised to x is increasing for all values of x. Now, if b is greater than 0 but less than 1, then b raised to x is greater than b raised to y if and only if x is less than y. This time, this means the exponential function is decreasing for all values of x. Remember that the resulting direction of the inequality is based on whether the base b is greater than or less than 1. Now, if the base b is greater than 1, your inequality symbol is retained. But if your base b is greater than 0 but less than 1, your inequality symbol is reversed. To illustrate the properties of exponential inequalities, let's have some examples. Solve for the inequality 4 raised to 3x plus 2 is less than 64. So the first step is to apply the equal power rule by making the bases equal. So we can express 64 in terms of base 4. So that will give you 4 cubed. Okay, 4 times 4 times 4, that is 64. Now, the base, you have now equal bases, which is 4. We can now we can have now the inequality, but we have to consider the base. Okay, so since the base is 4 and 4 is greater than 1, therefore the direction of the inequality is retained. Less than pa din siya. And then solving for this one, we can transpose this or subtract, applying the subtraction property of equalities. We can have 3x is less than 3 minus 2, and that will give you 3x less than 1. Dividing both sides by 3, that will give you x is less than 1/3. So this is now our solution set. So all the values less than 1/3. We can also express this one in terms of interval notation. So that will give you open parentheses to the negative infinity and 1/3 to close parentheses. So this is your solution set. Now to test whether your answer is correct, we will get a value for x. We will test a value for x which is less than 1/3. So for example, we have 0, because 0 is less than 1/3. So we will use the value of x which is 0. So substitute it here. You will have 4 raised to 3 times 0 plus 2. That will give you now 4 squared is equal less than 32. Okay, and then 4 squared, that is equal to 16. So 16 is less than 32. So this is true. You can still use other values less than 1/3. For example, you use -1 and you substitute it here. Your checking will always be true. So this will be your solution set. I hope that is clear. Okay, let's have another example. You have solved the inequality 25 squared greater than or equal to 5 raised to x plus 1. Make the bases equal using the equal power rule. So we can express 25 in terms of base 5. So 25 can be expressed as 5 squared times 2. Okay, the original exponent. So we have now 5 raised to 2 times 2 is greater than or equal to 5 raised to x plus 1. Simplify this one, we will have now 5 to the 4th power is greater than or equal to 5 raised to x plus 1. So this time they have now the same base. So we can have daw the inequality by considering the base. The base is 5. 5 is greater than 1. Therefore, the inequality, the direction will not be changed. It will be retained. So we'll have 4 greater than or equal to the exponent x plus 1. Now we transpose positive 1. So that will be on the left side, or applying the subtraction property of equality. So we will have 4 minus 1 is greater than or equal to x, and that will give you 3 is greater than or equal to x. But this one can also be expressed, uunahin natin si x, so you will have x less than or equal to 3. So dito nakaharap siya kay 3. So pag pinlip natin siya, nag-flip siya or nag-reverse, you can still have, dapat dito pa rin siya nakatapat or nakabuka kay 3. So, and this one can be expressed in interval notation as open parenthesis negative infinity up to 3 close bracket. Now, to check your answer, we will use the values less than or equal to 3. So, we can have 3 or 2, 1 and 0, but let's try 2. So, solve or substitute this here. So, that will be 2 plus 1. That will give you 5 cubed. 5 cubed is 125, and 25 squared is 625. And 625 is greater than or equal to 125. So this one is a true statement. Therefore, your solution set is also correct. So you have x less than or equal to 3. You can use other values again to check whether your solution is true. Okay, I hope that is clear. Okay, let's have another example. Solve the inequality 1 over 10 raised to x plus 5 greater than or equal to 1 over 100 raised to 3x. First step is to apply the equal power rule, make the bases equal. So 100 can be expressed in terms of base 10, okay? That is equal to 10 times 10, or you can have 10 squared. Okay, so we retain the expression on the left side, and we will work only on the right side. So this one, 1 over 10 raised to the power of 2, is the same as 1 squared over 10 squared. So pwede nating ilabas yung 2, that will give you 1/10 raised to 2 times 3x. Okay? Now, since they have the same bases now, we can now get the inequality. But again, we have to consider the base. So the base is 1 over 10, and 1/10 is less than 1. Since it is less than 1, the direction of the inequality will be reversed. So we will have x plus 5. Instead of having greater than or equal to, we will have less than or equal to. And then you have 2 times 3x, that will give you 6x. And then we solve for this one. So we can transpose 6x and then transpose negative 5. So positive 5, that will become negative 5. So you will have x minus 6x is less than or equal to negative 5. Simplify this, you will have negative 5x less than or equal to negative 5. And then we divide both sides by negative 5. Now, remember this. When you are dividing or multiplying a negative number to an inequality, your inequality symbol will reverse or will change. So, it will flip. So, again, from less than to equal to, babalik ulit siya sa greater than or equal to. So, your final answer will be x is greater than or equal to 1. Expressing this one to interval notation, we will have open bracket 1, and then you have to the positive infinity open parenthesis. So, you will use bracket since 1 is included. Remember your rational inequalities. Okay, you can go back again with the topic so that you will be able to recall how we express inequality notation into interval notation. Okay, to check whether our solution set is correct, so again, our solution set is greater than or equal to 1. So, let's use the value 1 since 1 is included. So, substitute here, that will give you 1/10 raised to 1 plus 5 is greater than or equal to 1 over 100 raised to 3 times 1. So, 1 plus 5, that will give you 1 6, and then you will have here 3. And then since this is 1/10 raised to 6, so that will give you 1 million. And this one is the same. So you multiply 100 3 times, that is also 1 million. So 1 over 1 million is greater than or equal to 1 over 1 million. So since you have here the equal sign. Now again, you can still test other values. For example, 2. And when you substitute it, you will still get a true inequality. So the solution set is greater than or equal to 1. Okay, let's have another example. Solve the inequality 3/5 raised to x plus 1 is less than 25 over 9. Okay, so we can apply ulit the equal power rule, make the bases equal. So 25 over 9 can be expressed in terms of power of 2, or to the second power. So we can express this one as 5/3 raised to squared. Okay, now but 3/5 and 5/3 are not equal. So we will make the base equal applying the negative exponent. So the exponent for 5 and 3 is 1. So when it is positive, you put it in the denominator, that will become negative. Likewise, if we have a positive exponent in the denominator and when we place it in the numerator, that will also make the exponent negative. So this will become 3 over 5 raised to negative 1 times 2, that will give you 3/5 raised to negative 2. So now you have now 3/5 as your bases. They are now equal. So we can now have the inequality, but we have to consider again the base. So 3/5 is less than 1, that is equal to 0.6. So it is less than 1, therefore the inequality is reversed. So we will have now x plus 1 instead of less than, that will give you greater than negative 2. And then solving for this, you will have x greater than negative 2 minus 1, so that will give you x is greater than negative 3. So in interval notation, we will have negative, open parenthesis, negative 3 to the positive infinity. So this will be your solution set. Okay, to check whether our solution set is correct, we have here x is greater than negative 3, so we will use the value negative 2, negative 1, 0, and so on and so forth. But let's try x is equal to negative 2. So substitute negative 2 to the original equation. You will have 3/5 raised to negative 2 plus 1 less than 25 over 9. So that will give you 3/5 raised to the negative 1. And then simplifying this one, since this one is negative, so that will give you 5/3 is less than 25 over 9. If you're going to get the value of this in decimal, 5 divided by 3 and 25 divided by 9, that will give you 1.67 is less than 2.77. So you will have here a true statement. So negative 2 is a solution set. Okay, again, test other values to know whether your solution set is correct. Okay, that ends our discussion for today. Again, visit your Google Classroom for your output, and then kindly subscribe, like, comment, and share. Thank you. And God bless you all.